Hey guys, Miss Johnson here. We're taking a look at 7.5 today. We're talking about operations with radical expressions. We're going to take a look at a couple properties that we have with radicals. The first one is the product property. Now, the product property of radicals tells us that we can take any set of radicals and we can split them apart. So if I had the nth root of the square root of a times b, that's the same thing as saying the square root of a times the square root of b. So I'm allowed to break those radicals down underneath the radical sign. For example, if I had the square root of 16, that's the same thing as the square root of 4 times 4. And the square root of 4 times 4, we talked yesterday about how we need to pull out pairs of numbers when we have the square root. So I can pull that pair out and I know that that's just going to equal 4. Now with square roots, it's pretty easy for us, but let's say we look at something like the cube root of 27. If I have the cube root of 27, that's the same thing as saying the cube root of 3 times 3 times 3. And I'm allowed to pull those apart because I know that 3 times 3 times 3 is 27. Now, we're looking for groups of 3 because my index is 3. Here I have 3 3's, so the cube root of 27 is 3. Okay. Same thing with dividing. I'm allowed to break apart that division as well. So the quotient property says that if I have the nth root of a over b, I can take the nth root of a and divide it by the nth root of b. So for example, if I had the nth root of, or I should say the cube root of 54 over 2, I can say that that's the same thing as the cube root of 54 divided by the cube root of 2. Well, I know that 54 is the same thing as 27 times 2. So here I'm kind of combining those properties because I'm going to break apart that 54. So 27 times 2 and also the cube root of 2 still on the bottom. Now, that cube root of 2 over cube root of 2, that's going to cancel out. Whenever you have a number over itself, it cancels out. So I'm left with the cube root of just 27. I've canceled the denominator, and we know that that's 3 from the previous example. Okay, so I'm allowed to break apart those fractions into two separate radicals on the numerator and the denominator. Let's take a look at that reminder box. It says simplified radicals will never have a radical appear in the denominator. If we have a radical in the denominator, we have to fix it. We're not allowed to have it there. Okay, to eliminate those radicals in the denominator, we need to rationalize. That must be on the next page. Here it is. We need to rationalize. Okay, so when we are eliminating radicals from the denominator, we're going to rationalize the denominator. To rationalize the denominator, we need to multiply by a quantity so that we have a perfect radical, a perfect root underneath. Okay, so let's take a look at a couple examples. If I have the square root of 9 over 5, that means I have the square root of 9 divided by the square root of 5. Okay, well the square root of 5 I can't do anything with, and that gives me a radical in the denominator, so I have to fix it. Since this is square root and this has an index of 2, that means I need a pair of a number. Since I already have one 5, I'm going to make a pair by adding another 5. So if I multiply by a 5 on the bottom, I also have to multiply by a 5 on the top. So what that gives me is the square root of 45, and now this pair can come out front, divided by 5. Well, the square root of 45 had that 9 in it, and I know that 9 is a perfect square, so I can actually take that out. So if I had the square root of 9 times 5 over 5, the square root of 9, I know what that is. That's 3 times the square root of 5 over 5. Okay, there's my simplified radical. No perfect squares under the radical and no radicals in the denominator. That's what I have to make sure I take care of. Let's take a look at another example. In the next example, I'm looking at the cube root of 2 over 9. Cube root of 2 over 9. So now I need a group of 3 instead of a group of 2, or a pair. So in the bottom, I should say in the top. In the top, I have the square root of 2. In the bottom, I have the square root of 3 times 3. Remember, I can pull that 9 apart and call it 3 times 3. Well, I need a group of 3 in order to take that group out because my index is 3. Since I only have 2, I'm going to put another 3 in. Well, if I multiply by 3 on square root of 3 on the bottom, or I'm sorry, cube root of 3, then I need to multiply by the cube root of 3 on the top. So now on the top, I have the cube root of 6, because 2 times 3 is 6, and there's nothing I can do to simplify that. But on the bottom, I now have a group of 3 3's. They can come outside of my radical and be just a 3 on the front. I've canceled everything underneath. Now I have no radicals in the denominator. I can't simplify. Some of you may look at the 6 and the 3 and think, oh, I can simplify 6 and 3. They have a common factor of 3. Well, but it's tricky here because 6 is underneath the radical and 3 is not. So you can't actually simplify those. We have to leave them the way that they are. Let's take a look at number 1 and just practice breaking those numbers down. Now, the square root of 198. We all know that we need to look for perfect squares in 198 and see what we can take out, but I'm just going to practice breaking down that number. Let's say I make 198 9 times 22. Okay, because I just divided by 9 to see what perfect square would come out. Well, I'm just going to keep going for the sake of practicing. I know that 9 is the same thing as 3 times 3, and I know that 22 is the same thing as 2 times 11. So there's my prime factorization of 198. If I take this list and put it back underneath the radical, I have the square root of 2 times 3 times 3 times 11. Now, since my index is 2, I'm taking the square root. I need to look for any pairs of numbers that can come out. I have a pair of 3's. I'm going to bring that out to the front. So that pair of 3's underneath makes 1 3 out front. I have to leave what's left over. 2 times 11 is 22. So my simplified radical is 3 times the square root of 22. If I take a look at number 2, there it is, I now have 3 times the square root of 54. Okay, 3 times the square root of 54. So again, I'm going to start by breaking down that 54. 54 is the same thing as 9 times 6, and 9 is the same thing as 3 times 3. 6 is the same thing as 2 times 3. So this is my prime factorization of 54, and I'm going to take that and put it back underneath my radical. Now that 3 isn't out front just hanging out there by itself. Yellow, you can see it better hopefully. We have to leave it there. But if I put my prime factorization underneath, I have 2 times 3 times 3 times 3. And again, I'm looking for pairs because my index is still 2 here. I'm taking the square root. Look for any pairs that you can pull out. I have a pair of 3's right here. I'm going to bring it out to the front. So I have a new 3, an additional 3. I have the 3 that was already there. Underneath, I'm left with 2 times 3. And now I can put that all back together. When I pull that 3 out front, it gets multiplied. 3 times 3 is 9. Underneath, I put that back together. 2 times 3 is 6. So I have 9 root 6 for that answer there. Okay. Let's try one more example together. See if we can take a look at number 3. Actually, I'm going to pause the video and want you to pause the video and see if you can figure out number 3. And I'm going to skip to number 4. So you see if you can figure out number 3 on your notes. And let's skip to number 4. We'll take care of number 4 together. In number 4, I now have 2 radicals being multiplied together. And they both have an index of 2. They're both square roots. Since they're both square roots, I can take everything that's underneath and multiply it together. So that's what I'm going to start with. I'm going to put everything together. For the number part, I have 24 times 12, and when I plug that into my calculator, 24 times 12 ends up being 288. If I take x to the 6th and multiply by x, that means I have x to the 7th. And if I take y to the 3rd and multiply by y, that means I have y to the 4th. Okay, so that's the radical combined. I took those 2 radicals, put them together since they had the same index. Now I'm going to break it down and look for any pairs just like I had done in the past. Okay, so I know that 288 is 24 times 12 because I just multiplied that together. So I'm going to start there, and I'm just going to keep breaking this down. I'm going to have a long list at the end, but that's okay. 24 is the same thing as 6 times 4. 6 is 2 times 3. 4 is 2 times 2. 12 is the same thing as 3 times 4. 3 is just 3 by itself. 4 is 2 and 2. Again, this is just prime factorization that we've done lots of times. Now, for the sake of practice, so that we can kind of see where this is coming from, I'm going to write out the whole long list. I like to put my numbers together. So I have 1, 2, 3, 4, 5 2's, and I have 1, 2, 3's. I have 7 x's. X. And I have 4 y's. Y. Okay, so there's my whole big long list. Again, this might seem like it's a little redundant, but I just want us to get the concept of pulling out the indexed groups that are, oops, I'm sorry, in this case it's a 2, groups that are the size of the index. So I'm looking for groups of 2. Any group of 2 that I can pull out, I'm going to take out to the front. So here's 2, comes out to the front. Here's another group of 2, comes out to the front. This 2 doesn't have a pair, so it has to stay underneath. Here's a group of 3, makes 1 3 out front. Here's a group of x's, makes an x out front. Another group of x's, another group of 2 x's. That x's alone has to stay. Here's a group of y's. Here's a group of y's. Okay, now that's all the stuff that came outside of the radical. Let's take a look and find what's left over underneath. I have a 2 and an x, so I'm going to leave that underneath the radical. Then I just simply need to put it back together. I know that 2 times 2 times 3, 2 times 2 is 4, 4 times 3 is 12. So I have 12 out front. Then I have x times x times x, which is the same thing as x to the third. I have y times y, which is y squared. And then I have a radical 2x underneath. Now I'm simplified. Now I have all perfect squares out from under the radical. I have no radicals in the denominator, and I'm done with that one. That's going to conclude our video for today. Thanks for listening, and we will come back tomorrow and finish up our notes. Thanks for watching.